My name is Lukas Sliwka. I'm a CTO of a company called Grindr. Let's see, that works. And Grindr is essentially the biggest gay dating, online dating network in the world. Grindr actually pioneered geolocation services. So I'm sure many of you are on Tinder. So very similar technology Tinder is actually using like we do. The only difference is that Tinder is using a different double-blind system. We actually show all the guys that are around you, right? And we have a couple of problems that we need to solve because we're a global company. But here's the use case that I'm going to be talking about today. So as a Grindr user, I want to be able to reliably access Grindr service around the world and to have a consistent user experience, which is easier said than done if you have a lot of users using your system. So Grindr has presence in over 200 countries in the world. We have over 400 million downloads. And when you look at our user base, North America, Europe, and South America compose around 80% of our user base. So what does it mean for us? All this user base translates into around 10,000 API calls per second. We process around 85 million chat messages per day. We do around 2 million chat images exchanges per day. And there's a lot of images being uploaded as well from our user base. Unfortunately, all this traffic used to end up only in the East Coast region in our Amazon cloud, which meant that if you look at the response times and the user experience of the users in the world, if you were in North America, Central America, Europe, your response time was acceptable, but the further you went out, like Asia, for example, Australia, your response time was not that ideal. And if you actually measure that and compare it to the organic growth of our user base, it is very, very similar correlation, right? So I think that when it comes to growing your app, making sure that your user experience, your response time around the world, that's very important. So how do we solve this problem? Through Amazon services and the other cloud providers, the key is to essentially bring your infrastructure and data as close to your customers as possible, right? Which meant that we needed to deploy 5 different data centers around the world and utilize Amazon Cloud to do so and implement something geo-routing and also data replication between those different services, different data centers. What that translated to is essentially much better response time for the users around the world. But once you start distributing your infrastructure like that, there's some pretty significant engineering challenges that you need to start solving. Let me talk about some of the technologies that are being used in place here. So we leverage very heavily managed services. And the reason for that is because managed services allow us to reduce our DevOps footprint and be able to manage all these distributed data centers with reduction of costs, and I don't have to maintain staff in all these different regions. So managed services allow you to essentially leverage technologies like Amazon Dynamo, Amazon SNS, SQS, Elastic Cache, to essentially deploy and configure all these services with the minimum DevOps footprint. The problem with this infrastructure that you see right now is that all the data actually still ends up in the US East and is being then replicated out, right? So this is not the ideal situation if you want to have an infrastructure that has high availability from the perspective of your data centers going down. So let's say if my US East region goes down for some reason, then everyone else is dark. So when you're talking about designing your distributed cloud architecture, you need to think about those things and try to design your API stack in a way so ideally each of these regions should be self-sufficient and then pick up the traffic if another region goes down. There are Amazon services that allow you to do that, and Route 53 is a good example of a good Amazon-based DNS routing, geo-DNS routing service that can also listen for how other data centers are performing, and if someone is not performing very well, they start distributing traffic to other data centers as well. This is also give you a quick snapshot of the technologies that we're using. Now, so what is the answer to the question of how would you replicate all the data across these different data centers and provide this very elastic, very high availability infrastructure on the global scale? Well, one of the things that I can tell you is that the biggest problem is data replication. So you need to be looking at technologies that allow you to replicate data from one data center to another, not only when it comes to the reads, but also the writes that you're doing. So Amazon RDS is not a good choice for that, because Amazon RDS does not support multi-master replication, but there are other technologies like DynamoDB, for example, that would allow you to do that. There are other databases that also allow you to do that. So when you're designing your architecture, you need to make sure that each of these data centers is using technologies that allow to replicate data to another data center. One thing that's very specific for us is that we don't care much about latency when it comes to data replication from region to region, because people don't travel that fast, right? When you're using our app and you're looking who's around you to date, it's not like you're going to teleport from Singapore to New York in split second, right? So for me to have 30 seconds, 1 minute replication lag between data, it's okay. If I was a bank, obviously that's a different story. But for us, we are actually leveraging SNS and SQS, which is publish, subscribe, and queuing systems to shuttle data around, right? So each data center is actually listening to changes that are happening on all the writes that are happening in the network, and those are just replicated across the globe. That operation, the lag is around 30 seconds to a minute, right? But that is actually okay for us. Another thing that I wanted to also talk about is if you deploy this, then there are other more advanced concepts that you can start applying to even boost your response even further by using CDN providers. So the biggest one probably is Akamai. There are other CloudFront, Edgecast, Fastly. There are companies out there that you can use to front your RESTful APIs with and essentially allow them to start caching your data. For static, RESTful APIs is easy. For dynamic content is much more difficult. But some CDN providers allow you to talk to their APIs and invalidate content that they're caching. So for example, you can say, hey, I'm going to use Akamai. I'm going to front my APIs with Akamai, and then if someone changes, let's say, profile information, I'm going to call Akamai and say, hey, this user just changed the information, and validate the cache, right? So, but those are more advanced concepts that you can start playing around with once you have that in place, right? Thank you, and grind on.